Okay, welcome back. We're on the next episode. So let's take an equation of this sort. So we're going to find values for m. Let me write that a little bigger so that phi of x equals e to the mx solves d2y dx squared plus 6 dy dx plus 5y equals 0. So now this is actually a technique that we're going to talk about more later in the course, okay? But when we have an equation like this, so this is second order linear, and this is homogeneous because the right-hand side is 0. Okay, then what our plan is we're always going to assume this sort of solution, okay, and see what happens when we do this. So phi prime of x equals m e to the mx, and phi double prime of x equals m squared e to the mx. Okay, so we're going to have m squared e to the mx plus 6m e to the mx plus 5 e to the mx equals 0. So you see that there's an e to the mx on all of these, right? So we're going to write this as m squared plus 6m plus 5 multiplied by e to the mx equals 0. Now, e to the mx actually can never equal 0. So that means we need to have m squared plus 6m plus 5 equaling 0. Okay, so how's that going to happen? Okay, well, hopefully we've mastered solving equations like that. Okay, if not, then I will make sure and send you some videos on that. Just let me know. Okay, so m equals -5 or m equals -1. Okay, so we have our solutions are phi of x equals e to the -5x, or phi of x equals e to the -x. Now, actually what happens, okay, notice this is a second order differential equation, right? This is a second order differential equation. So remember what I said about how you have as many constants as you have the order, right? So you're going to need two initial conditions, or there's going to be two constants you can play with, okay? So we're going to actually have what's called a general solution. And that's going to be C1 e to the -5x plus C2 e to the -x. Okay, and the C1 and C2 are actually determined by our initial conditions. Okay, so if any of you are taking linear algebra right now, which I imagine at least one, But if any of you are taking linear algebra right now, then there is going to be some overlap between the theory you learned there and the theory you learned here, because this is a connected idea. Okay, these ideas are connected with things that we're going to learn in linear, or you're going to learn in linear algebra. Okay, let's do another. We're not going to do this one. We're not doing another like this. We're going to do another kind of equation. Find m for which x to the m solves 3x squared d2y dx squared plus 11x dy dx minus 3y equals 0. Okay, so this one's a little different in that you have the x and the x squared. I can't remember the exact name of this equation right now, but there is a name. This is a certain type. And this is the way that we look at how to solve this. The way that we notice that we do this assumption is that you have the x squared here, the x here, and then there's no x multiplying the y. Okay, so this is also going to give us, in the end, a quadratic equation. Okay, so if y equals x to the m, okay, then y prime equals m x to the m minus 1, and y double prime is m minus 1 times m x to the m minus 2. So what we're going to see happening here is that we're going to have 3x squared times m times m minus 1 x to the m minus 2 plus 11x times m x to the m minus 1 minus 3 x to the m equals 0. So what's going to happen here is that this x squared and this x to the negative 2 are going to give you combined so that you're left with x to the m here. This x and this x to the m minus 1 are going to combine so that you're left with x to the m here. So you end up with 3m times m minus 1 plus 11m minus 3, all of this multiplied by x to the m equals 0. So again, x to the m doesn't ever equal 0, except for at x equals 0, okay? So we're going to go ahead and treat it as if that's non-zero, and we're going to make this piece equal to 0. And of course, I can simplify that, right? 3m squared minus 3m plus 11m minus 3 equals 0. I realize I just sounded like an android saying that, but okay. 3m squared plus 8m minus 3 equals 0. So this one's a little trickier to solve. You can always use the quadratic equation. I factor if I can. I look for two numbers that can multiply to 9, taking 3 times 3, and subtract to 8. So I could write this 8 as 9 minus 1. And now I can do factor by grouping. Minus, remember I always take out that minus sign. Okay, so 3m minus 1 times m plus 3 equals 0. M equals 1/3, or m equals -3. So going back to the equation, let me move this a little bit. Okay, going back to the equation, what we're going to have is our solution is going to be y equals some constant x to the 1/3 plus some constant x to the -1/3. Okay, this is a second order, okay, differential equation, homogeneous, okay, since the y's and the derivatives of y are all showing up on their own, it's actually linear. Even though there's an x there, this is still linear, okay, because the y's and the derivatives of y's are all linear terms, okay? And I'm going to look up the name of this type of equation, and I'll put it on the PDF before I upload it. All right? See you guys in the next video.